and B10, which is the basic solution, right? So that way we have, I've covered hopefully all the bases, and all you have to do, right, is just think about like how do you apply it to different things in those scenarios. And just because, right, we're kind of running out of time, I have 4 minutes. And so the way that you approach this, you basically do the exact same steps that you would do for the acidic, right? So first things first, we just simply write out the two half reactions. So we have aluminum forms aluminum. Here, let me give myself space. Aluminum forms aluminum hydroxide 4 minus, right? So the first thing we want to do is we want to balance out the non-oxygen, non-hydrogen atoms. So we have aluminum, one aluminum, one aluminum. That's good. The next thing we want to do is balance out the oxygens. So we have 4 oxygens on the right. So that means that we have to add 4 waters to the left in this case. So now we have that balanced out. The next thing we want to balance out are the number of hydrogen atoms, right? So we have 8 hydrogen atoms on the left. We only have 4 on the right. So we want to add 4 H plus to the right side. So now we're basically almost at the end of like what we would do for the acidic part, right? The last thing we would have to do in that case is add in the electrons. Don't have to do that yet. The next thing we do now is we add in the same number of hydroxide ions to both sides as we need to neutralize the H plus on one side, right? So on the right side, we have 4H plus, so we would have to add in 4OH minus to neutralize that out. And then we would add 4OH minus to the reactant side. And so now, right, this cancels out to become 4H2O like that. So we have that. And so then, right, 4H2O, those cancel out. So what we have now is 4OH minus plus aluminum forms AlOH4 minus. The last thing we need to do is we need to balance out the number of electrons, right, the charges on both sides. And so on the left side, right, we have 4 negative charges. On the right side, we only have 1. So that means that we're releasing 3 electrons in that case. And so, right, so that's all balanced out now for that part. The next part, right, is going to be the MnO4, right? So that's going to be MnO4 minus forms MnO2. So the first thing, right, balance out the non-hydrogen, non-oxygen atoms. So that's manganese. Same on both sides. Next thing, balance out the oxygen atoms. So on the left, we have 4. On the right, we only have 2. So that means we have to throw in 2 H2Os. In that case, we've done that. Balance out the number of hydrogen atoms. So on the right, we have 4 H's. On the left, we have 0. So we have to add plus 4H plus in this case. So we've done that. Next thing, we have to add in then the hydroxides to neutralize out the OHs on one side. So we're going to throw in 4OH minus on the left and then plus 4OH minus on the right. So these guys neutralize each other, right? So that becomes 4H2O. And so now, right, we can balance that out. So these H2Os are gone. This is now 2H2O. So what we have is 2H2O plus MnO4 minus yields MnO2 plus 4OH minus. Now we just need to balance out the number of electrons. So here we have 1 negative charge on the left. We have 4 on the right. So that means we need 3 electrons on the left. So we have that. So that's balanced there in terms of the charge. So now we just combine the two of them. So what we have is 4OH minus right here. That cancels, 3 electrons, that cancels. And so what we have then at the end, nothing else cancels, is Al plus 2H2O plus MnO4 minus yields MnO2 plus AlOH4 minus, right? And that should be what I have here, right? So this is B10. Yep. So that's what I have in the key, right? And so that's how you approach it, right? So first things first, you basically go through the whole procedure that you would do for an acidic redox reaction, and then once you have that, you just simply neutralize out that H plus by throwing an OH on both sides, balance out the charges, combine everything, right? And then you get the result right here. So so that's how you approach B